without further ado, I'll get started. We all here. Go ahead, please have a seat. First slide, please. Second slide. This is our panel today. Third slide, please. Or next slide, yeah. This is a direct follow-on to what we did last year, and here's the panelists from last year. The concept here is that we were somewhat conceptual last year. We brought in the Danes. Colonel, thanks for coming. And talked about LCS, and Norb came in and gave his shtick, which is very good. And so that was a conceptual panel talking about things we could do. I see Norb, hello. And today, it's more of a status report on what we've done in the last year. So OpNav went off and did some real work. Cap Kilby's going to talk about that. The engineering community has gone off and done some real work. Admiral Sullivan's going to talk about that. The cost estimators have realized that they need to work on their models, and Nita's going to talk about that. The combat systems community has done some very good work over the last year, particularly in Aegis, but also in other areas. So Captain Durgan's going to talk about that. And then we've stood up a small group to lay out a roadmap to the future, and that's what Trent Gooding is going to talk about. So this is much less conceptual, much more sort of a progress report on what we've been doing in this area over the last year. And I believe we've made good progress. We've done a lot of good things, and now we're starting to get more specific and more specificity, if that's a word, into our plans. Before we get started, though, I have a couple of conceptual things to put out. Next page, please. Over the last year, this is a thought experiment or a thought model that sort of emerged as how surface ship capabilities are seen over the long haul. The black line is kind of what happens. We build a ship to a requirement, we anticipate the requirements, we kind of overspec a little bit, expecting some emergence of the requirement, and then over time, as the ship ages and the warfighting environment changes, the ship becomes less capable against that requirement. The ship's as capable as it was when it was built, but against an emerging, changing threat environment, it becomes relatively less capable. And then we do a big midlife upgrade, NTU. Some of you, a lot of gray hair in here, may remember the Terrier ships, Albany and Springfield and Boston, and those were big upgrades to the ships. They tend to be very expensive. You buy back a lot of that capability, which then starts immediately to erode. Another fact is we tend to buy our ships for 30 to 40 years of service life, and as has been shown in many, many studies, we tend to get about 22 to 25 years out of them, principally because we can't afford that big midlife upgrade. And that line, if you don't get the upgrade, that line continues to erode, and at about 22, 25 years, it's not worth it to keep the ship around. And so we don't. So we pay for 30 or 40 years, we tend to get about 25. And so I've conflated two issues here. So that's kind of the as is, that's the problem. Next page. This is Norb's slide from last year. I've described this as a big, slow-moving gear, which is the ship gear on the right. Ship design is pretty mature, fairly long. Once you pick an engine and a hull, you're generally not going to change either one of those over the life of the ship. Some technology inside the ship may change a little bit, but generally that's a 30 or 40 year design. The gear, the smaller gear on the left, the Combat System C4I, the reason we build the ship, that's a fast-moving gear. It's a spinner. It goes out at 18 months, 36 months, maybe 3 years. But that's changing pretty fast. And the essence of the issue is how do those gears interact? Next page. This is for those of you that like cartoons instead of documentaries. This is the same thing in a cartoon version. Next page. So in the surface Navy, the way we handle this is when we want a new missile or a new radar, we build a new ship. So what we do is take those two gears and we wire them together, okay? And when the little spinny one doesn't work anymore and we can't change it, we throw them both away. So in the course of between 1961 and 2012, and I picked those dates for very specific reasons, which will become apparent in a minute, we designed 16 different ship classes to carry those weapons that are listed up there, plus some more that aren't listed, mostly in the ASW arena, QQ-89 and stuff like that. So when we couldn't use, when the combat system wasn't relevant anymore, the only way to replace it was to buy a new ship, which we did. And you see, that's the destroyer thread there running along the bottom. There's a cruiser thread, there's a FFG thread. So that's how we've dealt with that. Next page. There's another way. USS Enterprise, built in 1961, decommissioned in 2012. They didn't wire the gears together. They put some intermediate stuff in the middle. So their fast spinny thing was airplanes. The ship didn't change, but the airplanes changed. So they could change airplanes and did, and listed out the principles on there. I know there were a lot of other ones. But the ship stayed in service its entire design life, maybe a little bit more than that. I defer to some of the nuclear folks in the audience about that. So that's a different way of dealing with it. We got the full 50 years that we paid for on the ship, and Enterprise was as combat relevant on its last deployment as it was on its first deployment, as it was on every other deployment in between. So next page. So the red line is what modularity gets us in terms of combat capability. We get a lot of incremental upgrades. The 18-month gear spins along as we like it, and when you need to change it, you change it. It doesn't cost very much. It doesn't take very long. The ship can do what it's supposed to do. It remains combat relevant its entire service life. So we get better ships, and we get our full money's worth out of a ship when we buy a ship. And we don't have to buy a new ship when we get a new weapon system. We can choose to do that, but we don't have to do it. So that's kind of the thinking that has emerged over the last years, specifically around this issue. Now, in the aviation world, in the aircraft carrier world, we were forced to do that. The ship design was a cross-domain platform, airplanes and ship domain. The ship designers were very comfortable with our way of doing business. We've been doing it for 400 years. But those darn aviators wouldn't comply with the rules. They kept doing it different. And as much as we beat on them, they wouldn't change. So we had to change the ship to accommodate what the aviators were doing. The difference now is we're doing it within a domain, within the surface domain, with ourselves. And so there isn't an outside forcing function. We have to do it ourselves, and that's what Captain Kobe is going to be talking about. So without further ado, I'd like to introduce Admiral Sullivan, well known to this community. Retired after 34 years as a commander in Naval Sea Systems Command. I worked for him a couple of times there, and he was also chief engineer at NAVSEA. He graduated with Naval Academy, I won't say the year, with a Bachelor of Science degree in mathematics, and holds dual degrees, a Master of Science in Naval Architecture and Marine Engineering, and Ocean Engineer from Massachusetts Institute of Technology, and he's currently employed by USEC Incorporated, a global energy company. Admiral?
Thanks, Dave. Thanks for giving me the opportunity to come back to the community and sort of be the motivational speaker for the day. I have this ship up here just to remind everybody just how much fun it is to deliver a lead ship of a class, right, to the press, to the critical acclaim of the ship didn't work right and had tons of in-serve cards and everything. And no one's listening to LPD 17 today because they're coming off the line very, very nicely these days. So we can get it right, but part of my thesis today, slide, is to talk to the community about the choice that we have. You heard it from the Secretary. Affordability is going to drive our business for the conceivable future. And we have a choice. We can follow our past practice that Dave just showed you with the destroyers, or we can do something different. And I would tell you, it's time to do something different. And I believe that if you look at our three pillars, I'll call them, of stewardship of our fleet, we're at a nexus in all three of them that provides us a very, very unique opportunity at this time where institutionally we can approach this problem. We have the forcing function of sequestration and getting out of two wars. Those are historic threats to the shipbuilding and ship repair industry, but they also represent historic opportunities for all of us to get on with how do we change the way we're doing our business. I would contend that after you looked at those two slides on destroyers and on aircraft carriers, that reducing our, I'll call them type model series of ships and warfare systems, because the warfare system for a combatant is half the cost of the ship these days, it's imperative. Now, I love doing new ship designs as much as anybody else, a lot of naval arcs in the audience. The problem comes from that new ship design translating it into the pain of a first-of-class delivery and the pain of many first-of-class deliveries versus just a few, and the lost opportunity cost to the nation as we restart and restart and restart the learning curve. And again, this is not for ships only, it's also for the warfare systems that go on them. And then the resulting decline in the number of combatants that we have in our fleet, down to 286 by this morning's count. So we have to design differently for life of ship, for maintenance, and also for the ability to modernize our ships without spending almost $300 million a pop for modernizing a destroyer and a cruiser. So let me talk about why I think it's now, and I'll speak to each one of these three pillars, acquisition, maintenance, and subsystem modernization next. Okay, so where are we in the acquisition piece? I would contend that we're working our way out of the logjam of lead ship designs. And you could see the list here. We've had a very, very rough 10 to 15 years as we've come through a lot of these first-of-class ships. But you know what? We're on the other side of that curve now. So now we get to think about, when you're not in the fray, what do? You work on tools, you work on philosophy, you work on approach. So now is the time. We've learned an awful lot of lessons. First thing, lead ships are hard. That's kind of an axiom. But multiple type model series, they don't only just stress the design workforce, they also stress the building workforce and also the logistics infrastructure that's got to go with all of those multiple type model series. And I would tell you that this community is responsible for ship thinking beyond the ship acquisition. And we had a question for Mr. Stackley this morning. How do you cost that out? And how do you make that, other than just paying lip service to, yeah, we're interested in life cycle costs, it's got to be a driver now. So the next round, can we apply the lessons learned? We do have a future surface combatant on our horizon, next generation warfare ship, amphibious warfare ship, and of course the Ohio replacement program. Can we set ourselves up for long runs of successful shipbuilding programs that are flexible enough to meet the needs of the service life of the ships? Slide. The second pillar, fleet maintenance. We are forward deployed. You heard about the lengthening cycles, and we've got the fleet represented and we've got the sponsor represented today. Our product is forward deployed hulls and combat ready hulls. And just to remind ourselves, if you have one ship forward, you got one going and one coming home, and then you throw in overhauls, and you're in a world of hurt because it's down to onesies and twosies in any particular theater. We continue to struggle with under-resourced maintenance. Are we turning the corner? It sounded like it today, but I'm not intimate with the budget anymore, so I'm hoping that comes true. What lessons have we learned out of the maintenance field? Again, multiple class baselines, multiple combat systems, every type model series of ship, every type model series, every software, hardware configuration of Aegis has a legion of folks that are doing great work, keeping them all up. But at my last count, I counted 16 surface ship type model series hardware, software baselines. And you could question how I counted that, but that's between LCS and the Aegis community and the SSDS community. Going forward, can we design our ships, starting with the next class, to make it so maintaining these multiple type model series comes together in a way where we're not struggling to just meet the needs of so many different types of commodities. Slide. And then the modernization piece. I'm very mindful of Dave's curve. Wouldn't you like to keep your ships at that higher level with small curves as opposed to the giant? Well, we degrade the combat system, or the combat effectiveness of the ship, and then we have to pay a huge amount of money in the middle of the life of the ship in order to get it back up to a combat readiness. I want to talk about the life cycle of a ship a little bit. Mr. Stackley again said that the attention span of the Pentagon is the FIDA, but we're ship folks. If you think about it's 8 to 15 years from concept design to delivery. It takes us 2 years to go out and test the ship and run it through its shakedown. And then if we're lucky, we're building the ship for 10 to 15 years with an exception of the DDGs, which are really a great long run. And then an individual service life somewhere between 30 and 35 years, 50 years for the aircraft carriers. How do you build a ship to be combat effective 70 years from the day you've designed it? You don't know. You don't know what systems will go on those ships. So you have got to think differently in making them upgradable without gutting the ship. Again, lessons learned, very expensive to rip them up and upgrade them. And every time we take a ship off the line with 286 ships, surface combatants are, how many we got, 120? Sure. About 120 surface combatants. Every time you take one of them offline for over a year to upgrade it, that's warfare effectiveness that is not forward deployed. So we have to do a better job of that on a go-forward basis. Slide. So just to set up the rest of the team here, as you hear from the rest of the panelists, I feel it's time to seize the moment. We've been here before. There are folks in this audience that will tell you all about modular construction, will tell you all about modular weapon systems. I don't think we went far enough on the Spruance class. I don't think we went far enough on LCS. We have to extend it to the ship and to the cost methodology. So there are some realities. The budget won't go up unless we get a bigger share of it, and I think that's a very, very large stretch for anybody. And our warfighters can't perform if we don't have the numbers out there. And driving cost out of our ships and out of our combat systems can in fact result in more ships. You've seen that in the Virginia class, you've seen that in the DDG 51 class. You drive enough cost out, you actually can get more ships. We all need to work on that.
Thank you, sir. Next, I'd like to introduce Captain Jim Kilby. He's currently assigned as the Deputy for Ballistic Missile Defense at Aegis in the Surface Warfare Directorate on the OPNAV staff. He works for Admiral Roden, who spoke last year. He's also a graduate of the United States Naval Academy. I won't give you the year for the opposite reason I didn't give you the year for Admiral Sullivan. He's an Aegis naval officer to the bone, commanded Russell and USS Monterey, where he performed the first deployment in support of European phase adaptive approach for ballistic missile defense. Jim?
Hey, good morning. Thank you, Admiral. Before I start, we have been discussing what's changed between last year and this year, and I talked to Trent Gooding before we started, who I think you'll hear later. OPNAV typically comes up with requirements that drive to performance of a weapon system against a threat or anticipated threats. And what's changed over the last year is a discussion or an ongoing discussion with PEO ships and IWS and other NAVSEA organizations about what I will refer to later on in my brief as the ILITs, what those ILITs get you, and how we can better adapt this ship to get beyond 22 years. So the following few slides will lay that out, will lay that journey out. We are increasingly interested in total ownership cost. The establishment of the N9 Directorate and the OPNAV staff puts that squarely back in the resource sponsors' bailiwick, which is manpower, training, and the maintenance of those ships for their lifespan. So we're interested in writing requirements that help influence that as we drive down the road of this new type of technology and ship. Next slide. Before I get into the meat of it, I want to just anchor a little bit on Admiral Roden's piece of ASNE, where he talked about undersea dominance, the war at sea dominance, and then IMD dominance. So we've been involved in two significant campaigns over the last 10 years. Those disciplines have allowed us to maintain those wars, but as Admiral Lewis indicated, threats and other pressures of the world are causing us to look at those three areas specifically and say, how can we make those disciplines more robust? If you look at this chart, it shows our fleets today, and in the background, though it's hard to see, are all the sea lanes that exist today. Red and yellow are the more highly transited routes, and blue less so transited, but they're sea lanes nonetheless. So sea control encompasses those three areas, and we have to be, as a Navy, able to go to all those areas and influence those regions of the world to execute the national policy that we are assigned by our government. So kind of as a scene setter, that's why we care about this so much. That's why we're involved in different thought processes to make our ships more open and flexible and adaptable and scalable in the future. Next slide. So you saw this slide from Admiral Lewis. A couple of just going around the horn, you know we're in a decreasing budget environment right now. In the lower left, you can see that fuel costs and manpower costs and other costs are going up. They have to be accounted for by us as we design those ships. The upper right shows existing warship classes that Admiral Sullivan and Admiral Lewis indicated, and they're expensive to maintain by their design. And if we can't get a design that's more accepting of those features, we're going to have to bear that cost in the future. And that's the focus of our effort, is driving those future requirements in the lower right, defining them in such a way that they generate a more adaptable and flexible ship in the future. So 2 points of this slide. We talked about kind of the horizontal red line, which allows you to update the ship and insert capability more often than a gigantic midlife modernization. But another significant point is the red line starting later than the black line for combat systems insertion. So if there's ways for us to procure and install that combat system at a later date, we'll get more runtime out of it before we have obsolescence issues. So that's kind of the going-in position, is how can we set up the construction of the ship and define that requirements to insert that at the proper time, and then how can we engineer it in such a manner that we can more easily update it. And I'll talk about some examples of what some of those requirements might be in the future as we work through that, and how that's going to drive a specification for the ship design. Next slide. So we've gone down some of the journey in modularity with LCS, and you can see on this slide simply that the modularity is broken down into mission systems, which are supplemented by support equipment, which derives a mission module. And then when you add the other elements, people, training, et cetera, support crew, you get a mission package. So that's how that works in LCS. And LCS is at sea today. We're committed to that, and Captain Dave Welch will come talk to you about that this afternoon on how that program's going and what we expect from it in the future. What I want to talk about a little bit is a different kind of modularity, but system modularity, and how we can work that into the future. Next slide. So Admiral Lewis said I was going to talk to you about what we've done for the last year. Shortly after ASNE and meeting initially with Trent Gooding and a bunch of other folks from NAVC, we realized that we, OpNav, hadn't engaged at that level before. And we realized that within the first couple minutes of the meeting, because we got some pushback, or not pushback, but engagement, surprise even, that we would care about these kinds of things, because there are elements of NAVC who have been working them for a long time and haven't got the pull, I'd say, from the Pentagon, and they were starting to see that pull. So there's a little change that happened early last year, and that developed into a 90-day war room effort where we got together with NAVCO5, POIWS, PEO ships, and other organizations, Carter Rock, and we tried to understand what we were looking for. We tried to define some of the terms of modularity, scalability, adaptability, flexibility, and understand why we were interested in them, they would give us, should we value them. And from that effort, we came off with a better understanding of those things. We went down to Newport News and looked at flexible infrastructure as that's being built in the third deck of carriers and tried to understand what that would give us. We studied Aegis Ashore, and we'll talk about that example later, but what does that construction process give us? And we engaged in a study funded by N81 with 96, which we call our Future Surface Combatant Study, where we looked at different designs. And we broke up mission areas between kind of a fleet architecture attack on what we thought we would need to do in the future and what size ships we would need and what missions they should have. And when you assign a mission to the ship, what kind of thing does that drive to the cost of that ship and size and delivery of that capability? So that effort ended probably November, December, and we're proceeding on our next step, which is a CBA and a bunch of other steps in the JSIDS process to more predictably and with reason approach what our next ships should be and what capabilities they'll have. So you can see around the horn here, some of these things are things that we think a flexible ship or attributes of a flexible ship would have. A common source library or an open architecture of combat source software, which drives the combat system. Flexible infrastructure to some degree, which allows you to insert capability easier, vice cutting, welding, and removing interference and replacing. And the definition of standard interfaces, which will drive the capabilities that we can accept in that ship in the future in the space that they're going to live in. So a lot of these things kind of come up front as opposed to building in the back end. And if we work with that design in mind, and you'll see some things on the next slide which lead us to that, I think we'll end up with a ship that's much easier for us to maintain in the long haul. New weapons and sensors and antennas, understanding what service life allowance we need to accept those. We talk a lot about lasers and railguns. There's challenges there with cooling and power and battery storage that we have to work through, but that's all got to be encompassed in that ship design at the beginning to accept those technologies and those capabilities in the future. So we've been busy at this. It's a different role for OpNav, and we're turning those thoughts and understandings that we've gotten from the war room effort and the study into how do we build that into a requirement, which will then influence the acquisition side of the house and how we build those ships. Next slide. So we start out with the goal at the top. What we need to do is divide a ship or a class that will last beyond the 22 years we talked about. We think the ILADs under the requirements are things that have to be defined in requirements document from OpNav to get at the specific things those things bring, from maintainability to modularity, how much modularity, what kind of modularity, flexibility to be able to adapt to the future and insert capability. All those things are important for us to now address in requirements documents. The CNO signed out in August of 2013 a requirement for us to include SWAP-C now in our requirements document, and he's looking at CDD's capability definition documents in the future to not only address what can this do for me tactically and in performance, but how much is it going to cost, and where are those costs going to occur, and what is the first unit cost as opposed to inline production once we get the stream up and running. And then the technologies below allow us to insert that capability more easily and update that capability. So if I build a common source library and I can update it once and fix it once, then I can procreate that benefit into the future as we're doing now with Baseline 9. If I define supersets of equipment to attack a warfare area that I can use on multiple ships, I'm going to reduce the amount of school and training and NECs I have to have and get that performance across the board. I talked about flexible infrastructure already, And in design for modular access routes, if I do things a little more expanded than we've done on Aegis CGs and DDGs, where we've cut access holes and soft patches to move engines in and out of the ship and the main space, if I attack that same approach with combat systems gear in the future and the maintenance gear I need to maintain it, then that will allow me to more easily and quickly adapt those ships. So I wanted to talk about Aegis Ashore just for a minute. The design of that ship, or one of the requirements of that facility, was to relocate it within 90 days. With that requirement, the Missile Defense Agency engaged industry, specifically NASCAR and other folks, and said, how can we build a combat system so we can rack it in and rack it out within 90 days? And that drove industry to come up with a skid system, a foundation system for the combat system that's common, with wheels on it that allow you to plug in and plug this into a backbone to install that combat system and quickly move it, preserve it, and reinstall it later if I need to. That requirement drove that design. And that requirement has allowed Aegis Ashore to make quick updates in PMRF and now in the New Jersey site, which is going to go to Romania, to make that site more adaptable. So if we can not serendipitously find requirements, but build them in with help from industry in the front end to help drive that design, that's what we're interested in doing. If a requirement exists to not use hot work, that's going to drive design. If a requirement exists to do an overhaul in less than 90 days, that's going to drive design. Those are the kinds of things we're interested in doing, and we need your interaction and help to do it. Last slide. So this slide just shows you that other folks are doing it. Other nations are building modular ships. There's many different classes, and I won't go into them all here, but the MECO class allows 11 countries to take the same design and build capability. Many of these ships have varying sizes of Mark 41 VLS. Many of these ships have Spy-1D and F radars. So we are looking to adopt some vision of this similar modular, flexible, adaptable ship in the future. We're fascinated by it, and we need your help to do it. That concludes my remarks, Admiral.
Thank you. Well done. So you heard Secretary Stackler this morning say, start with a requirement. So if the requirement is shoot down a missile at 100 miles, ship goes 32 knots, we're happy to do that. If the requirement is I want a ship that's combat relevant for 40 years and I want to be able to upgrade it in 2 months, we're happy to do that too. We don't know how to do that just yet, but we're happy to do that. And so that's really been a huge progress in the last year is really bringing the requirements process into this and saying, look what we can do if we work together. And tremendous progress as Jim has outlined. The next speaker is a reformed aviator, aviation engineer. He started in NavAir, cost engineering. He moved on to NAVC and did combat systems in cost engineering. And then he saw the light and became deputy program manager in the new program office, PMS 385. Stood that up and did that for 2 years. And then I think you, Admiral Sullivan, didn't you pick him to be 017, 05C? Yeah, so he was picked by the man 2 spaces to his right to be the lead cost estimator for the Navy for shipbuilding. Tremendously experienced. I've worked with him now for quite a while, 6 or 7 years. Yes. Hugely experienced and very, very innovative, as you'll see in a minute. He has a bachelor's degree from North Carolina State University in aerospace engineering and a master's degree in systems management. Nita?
Thank you, sir. So when I moved from NavAir over to NAVC, the first question they asked me is, hey, Nita, you've been working on airplanes. Are you sure you're going to be able to work on ships? And when my response was, hey, if I can estimate and evaluate an object moving faster than the speed of sound, I think I can do that on a 35 or 20-knot ship. Next slide, please. So the age-old question, why do naval vessels cost so much? So about 75 years ago, the Secretary of the Navy was asked that same question, and the response, in summary, on the left-hand side is, increased complexity and capability of our vessels are driving the cost up. Lower procurement quantities. So imagine this is in the 1930s, 40s, we had low quantities. And then we're incorporating specialized materials and systems into our platforms, and that's driving our costs up. And then finally, the diminishing vendor base has an impact on what the cost of our ships are going to be in the future. So imagine that. In 1939 they were saying that. Do you think we can say that today? Probably the same response if the secretary had to testify. So the age-old question. So one of the things I like to do from a cost estimating perspective is look at the facts. Next slide. So fact, density matters. So before I even estimate, if you just plot out the outfit density on the y-axis versus the light ship weight on the x-axis, you get essentially the 5 families, okay? At the top left is the submarines. We all know how dense those submarines are and how light they are compared to other platforms. In the bottom right, aircraft carrier, very low density, if you will, but high platform weight. So facts matter. If we want to be able to impact the cost of our platforms, including the systems that we put in our platforms, we have to look at what it does to density. Next slide. So if we plot out a typical surface combatant and we Pareto cost versus weight, and so you can see, everyone would know the hull itself is heavy, a lot of weight. Over 50% of the weight is in the hull. Yeah, you look at the cost of that 50% of the weight, less than 10%. Okay, so weight is cheap. Okay, as Admiral Lewis keeps telling me, air is cheap, right? You can build a big box and it's going to be cheap. Now look at the C4I and combat system and armament. So very low weight, but look what the cost is. One of the biggest cost drivers in a surface combatant is the C4I and all the associated hardware, software, and infrastructure that goes in to own and operate that software and hardware. So again, no new news here. That's one of the areas we're focusing on, and with the flexible technologies and processes that we've been assessing and evaluating over the last year, this is one of the areas that we have definitely been diving into. Next slide. So how do we do that? So if you break up the spectrum of our cost estimating, on the left-hand side, we call that the pre-AOA and the AOA phase, when the requirements really haven't been finalized or laid down. And so we're in the process of doing trade-off analyses, right? Cost versus capability, what's the right systems, what's the right propulsion solution, C4I solution, HM&E solution. And what kind of methodologies do we use there? Weight. Essentially parametric, weight-based, dollar per ton, man-hour per ton, estimating relationships, and that's because it's a function of maturity of the design, if you will. On the right-hand side, we get into contract award and we get into post-delivery, if you will. Then we start getting into the bottoms-up engineered methodologies, which kind of makes sense, and into the EVM, obviously evaluating progress against a signed contract. So our goal with this study over the last year is to try to move a lot of our analyses that we do normally, post-award time frame to way up front during the AOA, pre-AOA time frame. That requires a lot of data. That requires a lot of interaction with our engineers to be able to break down the potential solutions to our lower level. What is this compartment potentially going to have in it? What is the infrastructure that's going to drive the capability that's in that compartment? So we're down to the compartment and space level vis-a-vis just looking at it at a total platform level. So again, the current flexible processes and technologies that we're looking at is driving us to get more data, more depth into the data early on into the process. So in order for us to be able to get to the stakeholders, when we incorporate those technologies, what is the cost associated with that? And it's not just the design cost or the procurement cost, but also the ownership cost. How is this going to affect manning, fuel, maintenance, modernization? Because those are the key drivers on the ownership side. Next slide. So if you break out the construction, and I took the current fit-up that we're in, took all the platforms that we have in the fit-up, and did kind of a Pareto and a pie on what are the cost drivers there, and it kind of breaks out into labor, material, and overhead. So I kind of separated overhead to the bottom left because that's driven more by business processes and kind of industry practices, if you will. Excuse me. But if you focus on the labor and material side, so you can see on the material, the driver there is our direct buys. Those are essentially the pumps, the valves, the generators, the switchboards, all the things that make our platform operate. Large dollar items, if you will. And then on the labor side, you see hull there is the number one driver from a man-hour perspective, but again, that's one of the cheapest areas because, hanging steel or welding steel is, not that expensive. Then you get into the engineering, the electrical, the services and support, pipe, and then program management. Those are the key things that are driving our costs from a labor perspective. So how are the technologies and processes that we're implementing going to affect those costs? Because those are the things that we're looking for from a cost perspective when we get asked, is this going to reduce the cost of this platform or not? We kind of look at the data. So again, back to the facts. If we want to be able to get that more detailed information early on in the process, we're going to need more engagement with the technical community for sure, but also with the industry, right? Because they're the folks that are actually building and designing these efforts. We're just trying to, if you will, estimate what the potential outcome would be. Next slide. So current methods, if you look on the plans, which is essentially detailed design, it's essentially a parametric relationship between weight, volume, and density, and what it's going to take to construct the ship. That's the current methodology that we use. So that's not good enough when we're talking about doing trade-offs at the technology or process level. So we got to get down to the drawing count, the space, right? Down to the actual technology and what it's going to impact in the physical space or spaces if it goes across the platform. What are those impacts so that we can price that out from an engineering perspective? And we've done that, again, in the last year during our little excursion we did with OpNav and the program offices. We engaged very heavily and pushed back on the technical community to get a little bit more deeper into the details, which they're very resonant to do because, we got to make a decision here, and they kind of want to leave that decision space open. But in order for us to get more maturity in our estimating processes, we got to start making kind of those decisions and do some sensitivity. So it's not an absolute that that's the decision and we're just going to live with it. Again, early on, it's very cheap to be able to make those design changes. But once you get past the AOA phase and you start going out with specs and putting contracts out, that's when it becomes very expensive in order to do those. On the basic construction, again, current methodology, we use weight-based, mostly on the man-hours. We do vendor quotes on the material, parametric weight-based, ranges from 5 to 65% of the overall estimate based on the maturity of the design of that platform, and do we have any return data, or how analogous is that data to previous hulls that we've built. Then the GFE, which is the HM&E electronics and ordnance, that's usually a bottoms-up when we sit down with our combat system folks and HM&E folks to understand what are the various solutions that are potential, get a bottoms-up vendor quote analogy to history. So again, as we're going forward into this new realm, if you will, we got to get a little bit more detail and understand what are the potential weight, power, cooling impacts for this the GFE that's going to be coming into that potential platform. So again, incorporating those technologies requires more detail. So that's going to be my bottom line today is we need your help, right, industry and the technical community to be able to take that detail and convert it into a cost estimate, because I do not have a magic button that I just push that converts what's in your brains into a cost number that we can, go forward with. I wish I did, but I wouldn't have this job if I had that button. Next slide. So over the past year, essentially the technologies and the processes that we've been talking about essentially fall in these 11 pillars, if I can call them that, these blue boxes here. So on the left-hand side, you see the design approaches that enable flexible technologies. Design for production, what a concept. Functional element zones, modular access for routes, energy magazines, warfare system supersets. So those are kind of the processes that have been discussed, which then we want to translate into the middle block there in the green into hull commonality, parallel mid-body, integrated power system, aperture stations, distributed systems, flexible infrastructure, pre-engineered elements, and then standard interfaces for ship services. Because one thing we did learn is that in our distributed systems, water, power, cooling, all those distributed systems really drive the cost of our platform. So if we want to implement these flexible technologies, those are the areas that we want to go affect. And then obviously once the area in red, we're very comfortable because we did have a lot of data to be able to estimate hull commonality and integrated power systems. The items in orange, doesn't show up orange there, essentially are the areas where we need help. Because right now, we're basically using qualitative assessments from subject matter experts, okay? Those are the areas that we really need to get more data so we can build our cost estimating relationships. Because again, at the end of the day, when we're standing in front of stakeholders or the secretary or the CNO and they're asking us about what is the realism of our estimate, what's the confidence in our estimate, it all goes back to, you know, is it predicated with data, right, and analysis, or is it just somebody's gut feel or some discussion? So moving to a more data-driven environment, if you will. Next slide. So what are the benefits of flexibility that we've seen? So in the design phase, discussions within, you know, the technical community, and I've had an opportunity to go engage with the industry over the last couple of months, and I think everyone agrees there may be a little bit more of design effort required to design those flexible modifications into the platform, but the payoff is really near term. Probably within the first hull, definitely by the second hull, you can get those savings off the investment that you make. Construction, again, definitely we've seen that. I mean, in the commercial sector and even in the aviation sector, we've seen that. In the construction, there's definitely opportunities for reducing cost, and again, paying attention to that space, weight, power, and cooling environment. It's easier to build, increase opportunity for competition because it opens up the envelope for more people to be able to get engaged. And then obviously the ONS, operation and support, we definitely care about that. It reduces time in the depot, potentially reduces modernization costs because now instead of doing a lot of rip out, we're doing a lot of more modular, if you will, takeouts and put back in, if you will, that can reduce our cost. Easier upgrade the combat system. As I told you, C4I is a big driver in construction. It's also on the modernization side. That cycle is very fast compared to the HM&E, and so that's obviously a driver on the modernization side. And then getting to Admiral Sullivan, Admiral Lewis's point about we want to, if we're paying for a 40-year ship, we should get a 40-year ship and not, you know, dump it after 25. Next slide. So what we did over the last years, we did some notional designs, conventional and then flexible, if you will, and we did apply, again, some of the factors that we have and some of the research that we were able to do on the technologies and what the impact would be on cost. And it was very clear that both on the procurement and the ONS side, and obviously on the total ownership cost, the flexible variants did come out lower cost than the conventional ones. Now the key is getting into the detail. Well, you know, what were the drivers, and you know, what are the implications? Because a lot of those were driven by, again, subject matter experts, qualitative assessment, and you know, we're still in the process of researching how we get more detailed information to be able to do that analytical analysis that we all need to do. So how do we do that? So if you look on the left-hand side, we have our technical-based databases, cost databases, and programmatic databases. So right now, most of the technical information that comes through to us, if you will, is through an asset model. We all know what comes out of asset, right? Weight. And so what we need to do is be able to come up with some other models that we can potentially use that is incorporating some of the characteristics of what's going on with these technical, these flexible models. On the cost database, we have, you know, data going all the way back to 1970. The question is, how do we convert that into this new technical, flexible environment that we're moving forward with? Next slide. So in summary, data needs. This is what we need from you folks, both on the technical and the industrial base, if you will, because data is really the heart of how we can come up with the analysis to be able to convince the stakeholders that this is a worthy investment to move out on. Thank you.
Great job, thank you. Actually, what I said is air is cheap, bulletproof air is very expensive.
That is correct.
And next, I'd like to introduce Captain Tom Drugan. He's IWS 1.0F, Fleet Readiness and In-Service Aegis Major Program Manager. He also attended the U.S. Naval Academy, and I especially won't tell you when he graduated. He served as commanding officer of USS O'Kane, a fine ship. I helped build that one. He served as Special Assistant to Chief of Naval Operations and the Vice Chief of Naval Operations. He has a Master of Science in National Resource Management and a Master of Science degree in Operations Research. Tom?
Admiral, thank you very much. Pleasure to be here today. Spend a little time with the technical community, shipbuilding community, and add a little combat system flavor. At the end of the day, our Navy is a critical element of our national security. There's no question of that for us. The shipbuilding piece of that is important to us, even though it's a small piece of the global shipbuilding industry. It's really important. It's a fundamental, foundational piece for our nation's security. And this group, this technical community on the shipbuilding side, plays an important role there. As we go forward into the future, with the pivot to the Pacific, the re-emphasis on sea control, the emphasis on being able to have unfettered dominance to go where we need to go, when we need to go, remains a constant in our nation's national security philosophy and policy. And our Navy, all navies, at the end of the day, while measured by the number of ships, are truly measured by the number of warships that we field and deploy. The United States Navy has been a leader across the globe for many years now in that respect, but there are other nations that are starting to nibble away at our lead in the combat realm, and we have to pay attention, ensure that we pace the threat, and in the cases where we can, lead the threat. Today's conversation is truly about ensuring that when we build a ship, it runs and executes the nation's business for as long as it was planned to do. And that's been one of our problems in the past. We talked about the 22-year ship that was built and planned to last 30 or 35. And so the adaptable and the flexible ship, as we go through the lifetime, we have to be able to ensure that we can upgrade it so it's combat credible. It's got relevance in a combat situation. And the next turn, as we go through, we've laid a good foundation, but the next turn into the future means that the flexible and adaptable ship is not just a desirement, it's a requirement. And so it's great that Captain Kilby was here today to talk about the OPNAV perspective of that, which is spot on to help us actually drive to a solution in the shipbuilding industry. So we'll take a couple minutes here, focus on the combat system of combat systems, but I want you to remember that it's all about deploying that combat credible capability, ships, warships, overseas, doing the nation's business every day. And every single one is precious. We have to ensure that they reach their expected service life. If they are overcome by a threat and we cannot affordably upgrade that hull, that puts us at a terrible position of making bad choices between deploying that ship at risk or decommissioning it, as we've done historically. Next slide, please. So we'll fill this out. It's pretty sparse right now, but at the end, we'll fill this in and give you a better sense of where we are. Next slide, please. So a few years ago, open architecture was a hot topic, and how were we going to get there, and what were we going to do with it? And I think at the end of the day, I'll show you some examples, is open architecture and the flexibility that it brings and the ability to take a database of computer code and adapt it to different hulls and missions is no longer a mystery. It's a fact. It's in place today, and we're executing it. There's two primary computer sources, computer combat system libraries, if you will. The first one is the Aegis Common Source Library, represented in blue. And it feeds not just cruisers, but also modernized destroyers and new construction destroyers and Aegis Ashore and Combat 21 on the LCS-1 variant. So that's one combat system library of computer code that's feeding all those different ship classes with pretty significant differences in missions. The second one is a single source library, and this feeds the SSDS side of the house. Now, the SSDS side of the house is already deployed on a number of classes and ships, including aircraft carriers, both in service now as well as the future USS Ford, CVN-78. Also large deck amphibs, many of them are going through that upgrade now, as well as LPD-17. Again, this is a very adaptable combat system library of computer code that can be adapted to many hulls and missions. Now on the left there in the background, there's a common asset library. This is where the government has decided that it's our best interest to go out and contract for a very defined scope of work to deliver a very specific mission or a very specific function and capability, because we think it's important to have commonality across the entire Navy, and so those become specific functionalities that we put in the Common Asset Library, and then they feed into both the Aegis Common Source Library and the SSDS single source library. That's important. That allows us to make sure that we have common functionality, particularly in the interoperability realm. We did one turn with the System Track Manager, Track Server, which is now common across all the Aegis and SSDS platforms that come out of these libraries. And we're working on the second iteration, which will be MH60 Romeo vehicle controller, because it really shouldn't matter whether you're on a carrier or an amphib or a cruiser or destroyer, you still have the same helicopter to control, and you need the same functions. So it made absolute sense to do that in a common way and then proliferate it through the libraries and then to the platforms. So that's kind of an overarching architecture, but the important point is that we're there. We're executing, and this is no longer a mystery. Next slide, please. The other piece is the physicality of the combat system. Today, everything is stick welded and mounted, hard mounted. That's important. These are warships. Class A shock is a fact of life. We need to be able to not just go into a combat situation, but be able to fight through it, including the battle damage piece of it. USS Princeton was a great example. When she hit the mine, she was back up as the air defense commander within 10 minutes. Phenomenal fight-through capability is something that we cannot lose as we look forward to the next ship class and the introduction of these technologies. On the other hand, it's expensive when you want to upgrade. Every dollar and dime that we spend on grinding down and ripping out stick-welded foundations and then replacing them with new stick-welded foundations doesn't add a thing to our national security posture. All right? So we can focus that better, as well as reduce the time that it takes through those avails and make them more efficient and provide more predictability in mission accomplishment on the avail side by introducing, if you will, track systems, flexible infrastructure. These already exist in a few classes, particularly if you go on an aircraft carrier. You'll see it in some of their mission spaces on the gallery deck, the O3 level. And we're working on how to incorporate those into new construction DDGs to some extent, and then maybe some of the other new ship programs coming down the line. Now, there are some differences. Those spaces that they're used in today are not Class A. They're not Class A shock requirement. So we have that requirement on the combat system side. So we have to take what's there today and extend it into the future, but it's straight engineering work. Straight engineering work that can be done and should be done. In a future world, it would be great where I wouldn't have to replace the cabinet ever, and it would just be internal changes for the mission cabinets. We're not there yet. We are in a follow road with the commercial industry in terms of processors and the IT backbone. But at the end of the day, which we need to be, but at the end of the day, we need to follow that because that's the only way to do it affordably. And because they're expanding their form factor and not contracting it, we're having to change the cabinet sizes to accommodate. Flexible infrastructure, though, gets us to the point where we can efficiently execute an avail and get the equipment in and out that we need to without the hot work and without the focus on the industrial piece of it. We can focus on the warfighting quality of it. Next slide, please. LCS is a good harbinger of the future. It brings together not just the modularity of the combat system and the physicality of the mission modules, but also the ICD, the interface control document and definition that controls how those pieces talk together. So we'll take a second here and talk about some of the different pieces, and I'll focus real quick on the mission module. So we have the SUW mission module on LCS today. It's a box. It's a payload that fits in a station on LCS. It has a defined interface for air power, cooling, data, etc. It's a standard interface. You could put something else in that box besides the 30-millimeter gun. In fact, you could put a RAM in it, you could put a C-RAM in it, you could put a CWIS in it, you could put lots of the Mark 99 fire control system on it. So if we took just that box and just take a second and translate it into today's DDG, you could have easily 5 stations, the 3 fire control illuminators and the 2 CWIS. You quickly get 5, and there's room to add a couple more in some of the places. You could have 7 stations on a DDG today. Now, for today's DDG, we would have exactly what we have today. But in 5, 8, 10 years, new threat, new capability development, the change out of that and the upgrade of that combat system would be efficient. And that's important because it gets us to a level where we can effectively and affordably modernize the ships to the capability we need to meet our combatant commander needs overseas. The rest on the mission module, again, harbinger of the future on how to do this. It's right to have an interface control document. It's right to have stations. It's right to have payloads, and then what you do within those payloads, that's kind of the magic, right? You build the payload ashore, you bring it in, you change it out, and move it on. Next slide. So what I really want to sum up with is that this has been a journey. We have taken many, many steps along this journey. On the combat system and the computer program side of the house, we're in good shape with the Aegis and SSDS and the Common Source Library and the Single Source Library. And I would like you to consider for a moment DDG 53, the third Arleigh Burke ever built, that today is the world's most powerful surface combatant, period, even though she's halfway through her service life. And a lot of that is due to the power of the computer program that gives us not just self-defense, but area defense. Add a new missile, the SM-6, and all of a sudden you have an extended range missile and you have with an over-the-horizon capability, and you've extended your engageable battle space by 8 times what it was. We have work going on more offensive weapons, and the VLS is a good place for that. It's modular already, and we've shown that we can increase the number of missiles and accept those and integrate them into the combat system as a matter of course. John Paul Jones also has not just AW capability, but it has BMD capability. And importantly, it has IAMD capability, Integrated Air and Missile Defense, where I can do AW and BMD at the same time in most scenarios without a loss of capability in either case. Full performance. And we did it with the same radar. The consoles were a change of choice, so we changed out the consoles. That was a change of choice to give us a new foundation for the rest of the second half of her service life and the DDGs as well. And the rest of the magic was in equipment cabinets that are gray boxes but filled with fantastic computer programs. That's where the magic resides. So we see that in Aegis, and you're seeing those advancements starting in SSDS as well with CVN 78. And there's going to be phenomenal capability as she brings those two radars together, integrates them, and delivers the capability to the aircraft carrier. On equipment FI, again, we have it on the gallery deck on carriers today. We need to extend that into our surface combatant world so we can, which we have a lot of, so if you have a lot of availabilities and you can have an incremental increase in efficiencies during them, then you get more than an incremental benefit across the force. And payloads, again, LCS has already shown us how to do payload and station and ship-level ICDs. What we have not done is taken all these piece parts and concentrated them into a single platform. LCS is as close as you can get, but it doesn't have the flexible infrastructure pieces in the different compartments, so there's still a lot of hot work and integrated master schedules that are serial and very reliant on previous work that has to be completed and the industrial characteristics of those avails. But if we take those and we concentrate them into a single hull and all those attributes, we will have a platform, we will have a warship that is affordable to modernize and can pace the threat, if not lead it. That's good for us, good for the Navy, good for the nation. Next slide, please. So overall, this summary, again, we got the flexible infrastructure in the top left, and we're moving not just Aegis, but SSDS and even some of the other ship programs into common processor equipment and common display. In the bottom left, I talked a little bit about the combat system libraries. Those are important, and again, we're past the implementation stage of this, and we're executing on both SSDS and Aegis side of the house. And then finally, if you bring a new weapon system, and if it's got a modern interface, TCP/IP, in a modern computer language, it can be integrated. It is straightforward work. We know how to do it. So even highly complex systems can come in at an affordable rate and then proliferate across the force in an efficient manner. And that's all I have, Admiral. Thank you.
Thank you. Just as a point, the combat systems that are on JPJ is also the same combat system that's going on DDG 113. It's the same combat system that's going on computer program, that's going in Aegis ashore. So that is already happening. Those are already being proliferated through the fleet. So not having to write new code every ship like we used to do. So thank you. Okay, our next speaker, and the one that's going to bring it all together for us, is Commander Trent Gooding. He also graduated from the Naval Academy. I won't tell you when, but I was already a commander when he graduated. It's pretty scary. He's the Assistant Program Manager for the LXR Amphibious Ship Replacement Program. He's also the Project Director for PO Ships Flexible Modular Ships Initiative. So he's my point man on this. He also graduated from MIT with degrees in Naval Construction Engineering and Ocean Systems Management. Trent?
Thank you, sir. Good morning. It's a great privilege to be part of the panel. I'm really looking forward to the discussion and the questions, so I'm going to try to move quickly so we have time for that. I think we're within a half hour of completion here. So much of what you've heard today comes together in a very practical sense with the Flexible Modular Ships Roadmap effort. We began working on the roadmap last fall, and we're about a month and a half away from the target completion date for this roadmap. So my objective here is to describe the roadmap and talk about what you can do to contribute to the broader initiative that we've been talking about. Next slide. So there's many types of roadmaps. Let me start with a high-level description of what this one is about. We seem to have general agreement on the vision and the need for more flexible warships. But there are many options for making our ships more flexible. So the roadmap aims to show the potential stepping stones toward this more flexible ship future. And as we start to lay out these stepping stones, we should start to be able to discern a path or potential paths toward these alternative futures. And in the roadmap, we call these stepping stones opportunities. And you'll see a little more of that in a moment. Notice up in the title bar, it says version 1.0, meaning that we intend for this not to be the only roadmap on this topic. We anticipate that there are going to be future versions, and this road mapping process is going to continue perhaps indefinitely. And regarding scope, the scope of the roadmap it's a focus on surface combatants and amphibious ships, so loosely think the surface force. And as far as the level of detail, it's really governed by the objective of getting the roadmap out in relatively short order in about 6 months. Next slide. So the roadmap purpose, to identify plans and opportunities to insert flexible architectures and technologies in surface ship programs. I'm going to just quickly highlight the key words in each of these sub-bullets and give you time to kind of read them. I don't want to start talking about them because it'll take too much time. But again, the goal here, the vision, to achieve greater levels of flexibility and cost efficiency over the life cycle. Wider integration of flexible architectures and technologies. Alignment, prioritizing opportunities, and that's a tough one. You can read the rest of that bullet and just get a sense for the real difficulty. Much of that has been discussed. But if we can do that, then we should be able to guide our investments better. Building an information repository to aid in decision making. Give program managers what they need to be able to implement these solutions. And then other enablers. And the intent of the roadmap is to highlight these key enablers. There's not going to be a lot of answers to exactly how we go do these things, but this version 1.0 will lay out a lot of these big challenges. Next slide. So this is a visual compilation. You've seen a lot of this already, but it's really a compilation of the flexible architectures and technologies that we're talking about and that we're looking at in the roadmap. Again, this is all about decoupling the payloads and the platforms, decoupling those things that change more frequently from those things that change less frequently. So think of these as the key technical enablers in the roadmap. Next slide. This is our top level illustration of the roadmap. This is not comprehensive, it's not gospel, but it'll give you a sense of how the roadmap is bringing this together. In the top section, we're identifying windows of opportunity across ship programs and across time, and in the middle section, in the blue, we're mapping the technologies and the design and acquisition strategies that need to go along with those technologies and characteristics up to the SHIP programs to show these opportunities. And so what you can start to see through this sort of mapping is that in the near term we have a few opportunities. A little further down the road with LXR, a few more opportunities. And the idea is that by the time we get to a future surface combatant in the late 2020s timeframe, we should know how to do this at an entirely new level. And we need to work our way there. So that's really the idea with the roadmap. Underlying the mapping are the enabling business processes that are critically important. And I'll touch on those again in a few slides. So there are really two main views in the roadmap. One is the view from the perspective of the technologies, looking across the SHIP programs. And the other is the view from the SHIP programs, looking at the opportunities to implement those technologies and characteristics. And next slide. We'll stick with our example of flexible infrastructure. And this is really just meant to show you the kind of information that we're capturing in the roadmap. For each of the technologies, we're collecting information elements about what those are. This is just, these are the big ones in slide format. The description of the system, what is it? What are the benefits? The SHIP application. So this is where have we implemented this to date, if at all, and what are the projections for the future? And then the all-important implementation enablers. What specific things do we need to go do in order to make these technologies viable to get into our ships? Next slide. So this is where we shift to what can you do. The roadmap working group, the current working group, includes representatives from most of the surface community PEOs and SysComs, plus OpNav N96 and DAS and RDT&E. We've got many talented and knowledgeable individuals on the working group, putting in a lot of time, very hard work, collateral duty, and I want to take a moment to commend everyone and thank everyone for that. And then also, let me ask the working group members in the audience to stand. This isn't to embarrass you, but for those who have been involved in the working group, please stand up. I know a lot of you are, I can find you if you don't stand. And so you guys can sit back down, but the point of that is really to say one way to get connected to this effort is to engage with those who are currently involved in the working group. And so after we break, you're able to identify some of those. But as we go forward to pursue this vision of flexible warships, we've got to involve all the disciplines in the community. And in my view, the Flexible Warship Initiative is not going to be a program. It's a big group project. It's a massive group project, and it's got to involve many programs, really all of the surface ship community programs and organizations. So next slide. So what are the big challenges that we need to deal with? I've taken our top-level strategic enablers, as we call them, from the draft roadmap, and over to the left, I've annotated the who beside each one. So for flag officers and program managers, and really anyone in a position of senior leadership, ensuring strong central leadership and forming a powerful coalition. This is something we've talked about repeatedly, back to the war room effort in the summertime. And part of this is maintaining the vision and breaking down barriers. The next one, developing roadmaps. So this is for PEOs and SysComs. Continuing to develop roadmaps. And this is not just this roadmap. These include the system level roadmaps that need to inform and be aligned with the flexible ship roadmaps. And we're seeing that happening as well. For the operators and for the resource sponsors, providing the warfighting requirements. Captain Kilby touched on this, and these requirements are going to be absolutely critical to driving in these kind of architectures into our ships. And the example that Captain Kilby gave was the new KPP for space, weight, power, and cooling. That's huge. That KPP says right in the description that it's about ensuring that we are provisioning for future capability, and that provisioning for future capability is on par with warfighting capabilities. And the rest of these really for the entire provider community, then the rest of the enablers, establishing a business model. There are many elements under this item, including business case analyses, cost modeling, and developing contract language, specifications language. The next one, defining and managing the standard interfaces. And really more than that, developing the technical system architecture that is going to help us achieve this greater level of flexibility. And then investing in technology advancements and conducting risk reduction. Actually going out and demonstrating these sorts of approaches at SEEP. And last slide. So looking beyond the roadmap at the broader Flexible and Common Warship Initiative, this is a view of the many lines of effort that we suggest are integral to moving forward. The colors are my own assessment of our status in each of these domains, so there's plenty of work to do. And what I encourage you to do is examine this chart and see where you can play. That concludes my remarks.
Thank you.
Yes, sir.
Appreciate it. It was in doubt, but I might have succeeded as moderator. We have about 10 minutes for questions. I thought we might have too much time for questions. So thank you all for going a little bit long. I was sweating it. So I'll take a few questions. Sorry.
Admiral?
Oh, go ahead.
I wanted to just say a couple things before my question, and I think a lot of my question was answered by Commander Gooding, but I want to commend you and the whole panel for a tremendous presentation today, and I think as a pickup from what was done last year at ASNE Day, this is a great improvement. I think it's very exciting. I could see Jack Abbott down here jumping out of his seat, and he's been working on this for 40 years, I think. And I think it looks like we're really on track. But my question is, someplace, sometime, you have to pick a platform that you're gonna make the modular platform like LCS. I mean, I hope it doesn't go exactly the way LCS did, but that's it's a modular ship, and it's got a lot of advantages that we expect to benefit from in the future. So it looked like 2028 on Commander Gooding's slide was when you're going to have some kind of a ship. But you did have a lot of things going into LXR. This morning on the earlier panel, we heard the possibility that could be more LPD 17s because of risk reduction, things like that. Well, I'm not sure you get there if you do that, but do you have any plans to really start to focus this and get the money behind a program that would, a ship program that would be designated the flexible ship?
I'll answer that one. That was actually the purpose of the roadmap, was to identify those opportunities. You're right, the full-up ship is fairly far out there, but there are ships in the near term, Flight 3, LHA-8, LXR, sort of in that order, where there are opportunities where we can selectively implement some of these technologies. And the issue is, where is that particular program in its life cycle in terms of design and procurement, and where are those opportunities that we could take advantage of doing some of the things we've been talking about. So I would not envision putting a modular SSDS on on LHA-8. That's probably too mature of a design at this point to do that. It could happen, but it might be hard. It might be too hard. But we could do potentially a modular C4I suite. A common surface radio room is within the realm of possibility on that ship. It's fairly localized, and POC4I has a pretty mature vision on how to do that. So that was the point of the roadmap, was to identify those opportunities most mature to least mature, and with the end state desirement being that when we do a fully modular ship design, there's no new discovery going on as far as modularity. Everything that goes into that ship has already been done on another ship, and we know that it works. Now, there's certainly opportunities to do it sooner than that if we wanted to, but we're trying to, so it's sort of a risk reduction plan and laying in those opportunities. And then it's a program by program decision as to whether that particular aspect of modularity can be implemented on that particular ship. What we're seeing is modularity reduces cost. It becomes an affordability initiative as much as it is a future requirements or warfighting capability initiative. So the earlier implementations are actually being driven through the affordability opportunities more so than the warfighting requirements opportunities. Yep.
The answer should be the next one.
Right.
But that's
Which
pretty hard to execute.
Thank you very much.
Thank you, sir.
This isn't just a DASNE reunion. First of all, I'll pile on to what Ron said. A remarkable panel, I think. Corky Graham 30 years ago was right with his carrier of large objects. We've gotten there for surface ships. It's very obvious to me we're on a path. Survivable, sustainable volume at sea. When we talk about Enterprise or Ford, we did it on carriers. We did it on Virginia-class, survivable, sustainable, flexible volume at sea, where modularity is something that we know how to do. The question is, do we know how to estimate it and budget for it? And so I'm going to focus on NETA here for a minute. As density is a factor, as complexity is a factor, as the HM&E portion of our ships becomes a lower and lower percentage of total ship cost. Sully was right. He was gracious. He said 50-50. DDG is about 45% HM&E now, right? And the rest is warfare system and everything else that goes into buying the ship. And so NETA, what are we doing to make progress on really understanding from a cost research perspective the cost and building our parametrics for the warfare system side of the business, and then also, given that the acquisition cost is only, a percentage of total ownership cost.
20 to 30%.
Yeah, what are we doing on the other end? Since if we look at our budget challenges, I would submit that the acquisition community has done a remarkable job containing cost and pressing forward, and the growth in our budget has been on the personnel and operational side. So what are we doing to really understand the total ownership cost implications and how we factoring that into our model for total ownership cost for our ships?
Yeah, so again, over this past year, we've been learning to do that, to be honest with you. Again, a lot of the data and the models that we had before didn't get down to that level. They're very high level parametric. So we've been engaging with our community both on the technical side and throughout the Carter Rock and other warfare centers to be able to do specific pilot projects. And again, this notional design that we came up with over the past year was kind of our pilot on what data would we need in order to be able to answer that question. So right now we're using subject matter expert kind of qualitative assessments at this point. And what we really need is the data. We kind of understand the technical parameters that could be driving lower cost in the acquisition and the ONS phase, the total ownership cost, but we don't have the current data to be able to bring that to fruition so our stakeholders have confidence in that going forward. So we're in the very early stages of the research. And again, this past year really was a great opportunity for us to try to build that relationship with our research community to do that. So we're not there yet. I'm not saying we're there yet. As you know, sir, it takes time to be able to collect that data. The Ford class, we're learning a lot of that because they've implemented some of that, so we're getting that information, seeing how that can then relate to other platforms as we go forward. So we're in the early phases of the research, if you will.
I just want to add on one thing. The cost isn't all financial, it's opportunity lost.
Mm-hmm.
So when that ship is in a modernization for a lengthy period of time, it's not available to do the nation's bidding. And we can't lose sight of that. So we may, have to, as a requirement side, understand that and build that in up front so we can try to minimize that cost, that opportunity cost lost in the future. So it's a financial piece, and I think it's an availability piece as well.
Can I add one more even on top of that, which is it's a risk calculation for the deployed forces. However long it takes to develop a new system is fine, but often 5, 10, 15 years for a complex new weapon system. But if it takes 10 or 15 years to field it, we are not pacing the threat. We have to pace the threat at a minimum. So the modularity gives you the ability to do that, to be able to field more quickly.
I think my example of that is the new threat upgrade. New threat was in 1968. I think the first NTU ship showed up in 1982-ish. So not very new at that point. Sir.
Yeah, good morning. Dr. Chris McKesson, University of New Orleans. Excellent presentation. I won't keep saying that, everyone said. The challenge of incorporating flexibility in the ship design does actually make the ship design task more complex, because now instead of designing for a single point, a single level of effectiveness at day zero, we now have to take into account these additional variables that have been enumerated, and that's excellent, and we ship designers embrace that opportunity. In Trent Gooding's presentation, the very first slides contained the words prioritize, show, promote, guide, influence. These are words that speak of communication. In Trent's last slides, he said, but didn't write on the slide, breaking down barriers. It's a phrase that speaks of communication. So rather than asking Trent, let me ask the gentleman who graduated a little earlier, what are you doing to institutionalize a communication chain that will allow the complexity of the ship design process to be fully informed across the stakeholder community? We ship designers, I promise you, want to give you warfighters the best assets that we can, and the communication of the definition of bestness is multidimensional and challenging. Thank you.
Excellent question. Admiral Sullivan says he wants to.
Glad you asked. Unless you have a 70-year horizon, you're not going to get this done. So it goes from let's go to MIT, as we did in November, to talk to the next generation of ship designers in uniform, who, if you look at the program managers today, most of those went through the program up there. So let's first off start at the train the students, get the students thinking in this direction. That's been a couple of year effort on some of our parts. And then let's go to the other end of the food chain, where there's a meeting, I believe today or tomorrow, with Emma Roden, who is the sponsor, who's got a lot of the vision here, and trying to get that part of the community. I cannot overstress how wonderful it is to have the sponsor in the room talking this, okay? You see captains here. In a couple of years, they're going to be flag officers, right? We hope. And that's what it really is a labor of a multi-year coordinated effort to grow. I'm not talking just let's go talk about the next ship project. It really needs to be infused over a long chain of leaders who will sustain the systemic effort to go change the system, to put these items in place so that it's not a crisis when we try to jam this into the next ship program. So it's a long time effort.
I guess I just go along with what Admiral Sullivan said, and maybe I didn't convey that correctly, but we're trying to apply a disciplined approach from the N96 perspective on what we're going for, and not trying to run out and grab the shiniest orb on the horizon and say that's the answer. So some of these technologies, these ilities, have value, maybe some more than others. We don't completely understand that now. We're working with Nita and Trent and Tom collectively, where we show up in these efforts and put down our collar devices for a minute and really try to get to the business of understanding what we're trying to do here. And it's not just kill this air target at this RCS at that range. That's typically been our focus in the past. So understanding those other things that we've all talked about here, and how do we convey that correctly so we start the process from a design level down to get what we asked for. And I think that's what and we've got to set up that inertia and that momentum, that it's not subject to the name tag of the guy who comes in at my PRD or Admiral Roden's PRD. they just walk into this thing and they've got to keep it going because it's got so much momentum.
I'll just expand on that. Secretary Danzig, former Secretary of the Navy, wrote a nice little monograph, I think it was called Driving in the Dark, and he talks about our hubris in thinking we can determine things that are going to happen 15 or 20 or 25 years from now, as opposed to what actually we can predict and determine. So we live in a time right now of great change. I think what you're seeing is a recognition, and we're coming out of a time of great certainty. 50 years, we knew who our enemy was, we knew what our enemy was doing, and we could plan a 25-year missile program with some expectation it would be useful and it would work at the end. And that's not the case now, and I think everybody in the Navy understands that now, that we are in a time where we don't know necessarily what we're going to do 5 years from now, and so we need to build ships, platforms that have the capability to take the payload that we need that day to defeat that threat, whatever it is, and there's a reasonably high probability we're not going to know what it is until not too long before we actually have to have it. And I think the Navy understands that, Navy leadership understands that, and what's happening now is the engineering community needs to be responsive to that. We've had a lot of good thinking over a lot of years, so the tools are all there. The thought has all been done. Now it's a matter of tying it together as been described here this morning. So.
In academia, we've referred to that as 4D design in the time domain as well.
Yes, sir. All right.
Thank you.
Well, that concludes the amount of time we have. So I'd like to thank Glenn Sturdivant and Mike Good and the rest of my staff and their staffs for helping out set this up. And I'd like to particularly thank the panel members. I've got some coins for you, which I'll give you in a minute. And again, thank you all for attending and being attentive. Thank you.